Hi everyone, today we'll be going over an introduction to basic inequalities. An inequality provides a way for an interval with many solutions to be true, instead of just one unique solution as we have seen when solving equations. In this section, we will look at the way we can convert statements we use all the time into math notation. Students are usually surprised by all the ways one can represent four different statements, but once you see the connection, it can be fun and interesting to interchange the different symbols based on the situation. So let's first take a look at when we're talking about greater than. I once had a cold calling job for an insurance company. It was a really poor job and I only worked there for 6 weeks. My boss would tell the employees that we all had to meet our cold calling quota each week, which was more than 12 interested contacts per week. Write the cold calling quota as an inequality in as many symbolic ways as possible. So first, for the inequality notation, I'm going to define a variable to represent the cold calling quota, which is just like how many calls I would have to make out to random people to see if they were interested. So I'm going to let Q represent our cold calling quota amount. And so if we were talking about inequality notation, we would say that Q needed to be greater than 12. Okay, now other than inequality notation, we can also talk about interval notation, and that is where you have two values separated by a comma, and then we either put parentheses or brackets around those. So the left-hand side would be 12, and then we'd separate that. Since it goes on forever, I could make as many cold calling phone calls as I wanted. This would potentially go to infinity. And then because it's greater than and not greater than or equal to, I would need to put a parenthesis around 12. And infinity, although we like to talk about it, it's not a number. And so you can never attain affinity and it cannot be included in your interval. So we never put a bracket around parentheses. We always want a parenthesis around infinity. And then the two other ways is we could graph this on a number line. So number line. So maybe here's 11, here's 12, here's 13, and there's two ways that you can graph it on a number line, depending on like what textbook you're reading or who you're talking to. There's kind of two notations that people will use. And the first one is because we don't have 12 included, we'll use an open circle and then shade to the right to represent that our set of values can include anything to the right of 12, like 13 or 14 or 15 and so on. And then the other way that you can represent it on a number line is instead of using an open circle, I'm going to use a parenthesis. So I'm going to use a parenthesis like that and then also shade to the right. So those are the two ways that you could represent this statement symbolically on a number line. So now let's talk about greater than or equal to. You likely know a friend who uses their phone for much of their business responsibilities and notice that they need to buy at least 4 gigabytes of data to ensure they do not get penalties for data overuse charges. Write the friend's data usage as an inequality in as many symbolic ways as possible. So I'm going to again define a variable. I'm going to call it d and let d equal your friend's data usage amount. And so if we want inequality notation, we would say that d, since it has to be at least, we want to say it would be D is greater than or equal to 4 gigabytes of data. And then for interval notation, because we're including 4 as a possibility, we would put a bracket around 4 and then anything greater than it, so it can go up to infinity, and then I would put a parenthesis around that. Now we can once again talk about the two number lines. So here's 0, 1, 2, 3, 4, 5. Just gonna quickly draw another one down below it. Okay, so this one's different because it's greater than or equal to. So our symbol will fall on 4, and on the top one, instead of using an open dot, I'm going to use a closed dot to represent that our set of values does include 4, and then we want greater than or equal to, so I'm going to shade to the right. And then the second type of notation you can use is instead of a parenthesis, you can use a bracket around 4 and then shade to the right again. So that's what it would look like for greater than or equal to. All right, now let's talk about less than. It says an average adult male should try to balance their diet in such a way as to have a body fat percentage less than 20%. Write the body fat percentage as an inequality in as many symbolic ways as possible. So I'm going to create a variable once again. Let's call it B to represent male body fat percentage. So for inequality notation, we would say B is less than 20%. For interval notation, we'd have negative infinity to positive 20, and we would want a parenthesis around 20 because it's less than. And something that I just want to point out with interval notation, the smaller value always goes on the left-hand side. Sometimes students get a little bit confused about that. So just as a quick side note, if you created an interval, say something like this, like 5, 4, this is not an acceptable interval. Because again, when we're writing interval notation, the value on the left-hand side always needs to be smaller than the value on the right-hand side, so this interval does not make sense. Okay, so that was just a quick side note. Let's go ahead and graph these. So here's 21, here's 20, here's 19 on our number line. And then we want to graph less than, so in the top number line, I'm going to put an open dot and then shade to the left to indicate that it's less than. And then on the next number line, I'm going to use a parenthesis and then also shade to the left to indicate less than. All right, so this is the last one when it comes to inequalities. We're going to talk about less than or equal to. At some rides at a carnival, there are height restrictions. On a bumper car ride, anyone 42 inches or shorter cannot ride the bumper cars. Write the height restriction for those who cannot ride the bumper cars as an inequality in as many symbolic ways as possible. So let's set up a variable. let's say h is equal to the height of the writer. So we're saying that the height of the writer cannot be less than or equal to 42 inches. So that is the limitation. So basically the height, or h, in order for them to be able to write it, has to be greater than 42. But here we're just describing the actual restriction. So if we were to write this in interval notation, now, because this is like a real world problem, I would be happy to accept two different answers. And it's just, I guess, how you think about it. You could say negative infinity to 42, and we would put a bracket around 42. But in reality, you can't really be a negative height. And so if you're a person, you can't say like, oh, I'm negative 36 inches tall. That doesn't quite make sense. So another acceptable answer is you could say, have it stop at 0. And so you could say between 0 and 42 like that and have that be your interval. That's perfectly acceptable as well. So here's 42, 41, 43. Okay, so for the first number line, I'm going to use a closed dot and shade to the left, and then I'll use a bracket on the next number line and also shade to the left. So those are the 4 types of inequalities that we usually see in our day-to-day life, and this is how we would represent them using different mathematical notations.